Welcome to another Mount Holyoke Psychology Statistics Hub tutorial. This is your lab director, Natasha, with a research question for you. Sleep and academic course load have long been studied as predictors of stress. Imagine Mount Holyoke staff want to learn about whether sleep and course credits can predict the stress levels of Mount Holyoke students. Given our sample of 100 students, are the average nightly hours of sleep students report and the number of course credits a student is enrolled in able to predict the stress level of that student? What analysis can you use to answer this research question? When you have two or more continuous variables and you want to see if you can predict a change in one variable based on change in the other variable or variables, you can use regression. With our data, we will investigate whether we can predict the stress level of a Mount Holyoke College student based on their average nightly hours of sleep the student reports and the number of course credits the student is enrolled in. Each of these variables is continuous. Sleep is the number of hours students reported getting the previous night. Credits is the number of credit hours students report taking this semester, and stress is a self-rated score of how much stress students report on a scale from 1 to 10, with 1 representing very little stress and 10 representing extreme stress. So to run a regression using RStudio, we can see the code is LM in parentheses outcome tilde predictor, comma, and then data equals the name of your data set. We can save this as a model using the goes into symbol so that we can then view the output by taking a summary of the model. So using our variables, we could say model and then the goes into symbol, LM, stress, because that is our outcome variable, the tilde sign, credits and sleep. So you can use the plus sign if you have more than one variable that you're using. Actually, that should be lowercase, so I'll need to double check whether credits is also lowercase. And then a comma, oops, no, close the parentheses yet. A comma, data equals, and then stats practice. So let's just double check that stress and credits were both capitalized. And we can see, yes, credits and sleep are both actually sleep was capitalized. Okay, so we'll enter that there. Then we can close the parentheses. Now that model is saved, so we can say summary of the model. And here is our output. So we can see some important things. First of all, we can look to see whether the entire model was significant by looking at this final p-value. We see it's less than 0.05. So right off the bat, we know that this regression is significant. So we can say that credits and sleep together do significantly affect or predict the score of someone's stress level, given this sample of Mount Holyoke students. We also have some great information here. We have the adjusted R-square value, and that is the percentage of change in stress that can be predicted by the combination of credits and sleep. So in this case, 29.42% of the change in stress can be explained by changes in credits and sleep. And then looking at up here at these numbers, we can see that sleep significantly contributes to the model because the p-value here for sleep is below 0.05. Given that it's a negative value, we know that as sleep increases, stress decreases, and vice versa. As sleep decreases, stress increases. So we also know from looking at the credits p-value that it is not a significant contributor to the model, but we can have a sense of how it is affecting the relationship between credits and stress. And given that it's positive, even though it's not a significant predictor, we know that as credits rise, stress also rises, and as credits decrease, so does stress. But overall, again, looking at this model, we can say that 29.42% of the change in stress can be explained by the changes in credits and sleep together, and that this is a significant predictor. So remember, until next time, don't be mean, be above average.